we are waiting this moment to start to be online on YouTube. I will put a header, please. When we start to be on YouTube, put a link here on the chat that the people can share with other partner or other colleagues from the fire service or the companies. Now, again, welcome everybody. Thank you to be in this webinar. It's a pleasure to us to share all the information that we have. Today we have a wonderful instructor. He's our area manager from the West of Hazard Control Technology, Jeff Bonkowski. The idea of this training is try to talk 45 minutes and the other time use to answer questions. We are recording this webinar, and when we finish, we have a session of question and answer. Please, if you have some question, go to the chat of question and answer that we don't miss any of your question. And please, Jeff, introduce yourself and we're going to start this webinar with all our people.
Okay. Well, thank you, Hernan. Thank you, everybody, for taking the time out of your day to join us with this presentation today. As it says, today's presentation is going to talk a little bit about, the exceeding outdated fire protection standards. To give you a little bit of my background, I was originally a career firefighter. I had retired and started consulting. And through my consulting work and trying to find solutions for some of today's hazards and dealing with the fire problems that we're faced with, I came across hazard control technologies, and so I've been here and became this area manager. Through my career, like I said, I retired out as a captain. I was a hazmat specialist and a paramedic. So I devoted much of my career to learning as much as I could about how to deal with and protect the community and my firefighters from basically high hazard incidents. When we talk about hazard control technologies, right now, currently, we see new hazards that are being presented to the fire service. And in a rush, you start to see a lot of new products that are being introduced to meet those hazards. With hazard control technology, we're a little different. We've been around since 1997. We've been here for 27 years. And what's happening with our product is people are testing it against these new hazards and we have 27 years around the world of testing with the product. So this isn't something that's new and just coming to the surface. Again, as I said, I've been with the company and I've got 41 years of service and experience, and been with hazard control technologies in some way, shape, or form since about 2012. So what I want to do is I want to start getting into and talking about, the challenges. Because when we sit there and we start to look and we see, again, if you've been in the fire service for any length of time, you had the old natural materials and fibers and the time between the ignition and actual free burning, you had some time to get on scene and be able to keep a fire possibly to a room and contents. Or sprinkler systems were able to possibly control a fire until the fire department arrived. And now we're seeing things become just a little different. We're getting into these massive, massive structures as far as distribution centers and stuff. And again, because of the fact that, we're trying to get away from cutting down our forest and getting away from those hardwoods, we're getting fast grow wood products, using the wood, and instead of actually making them out of the lumber, we're chipping it up and adding resins and glues and fibers to them and things like that, and making them all with synthetic, which are, again, strong, lightweight. Problem is, they burn hotter, they burn faster, and they give off a lot of toxic byproducts. When we sit there and we get into it a little more, and we start talking about all the different areas, again, let's look. I mean, as far as some of the things that used to be made out of heavy steels, we're either going aluminums, titaniums, Magnesiums, going to something that might be a little bit lighter weight. With the power industry, the changes that are taking place there, when we sit there and start looking at the battery energy storage systems, your best units, parking structures. We'll get into that and the power a little bit more as we go into the presentation, but just recently in Florida, we had a fire that affected a parking structure. Yeah, codes and things are changing because of EVs, but we start looking at Luton Airport, their fire at the parking structure. We look at the one here in Florida. They weren't started by EVs. The report that I saw was BMW down in Florida. We look at again their warehousing. I mentioned the size of these. We're getting into massive, massive structures, and in some cases, multiple stories that cover expansive areas. They can be huge if we sit there and we continue to look at the way sprinkler systems are designed today, using today's standards. In 3, 4, 5 years from now, is that going to be sufficient? If you've got a warehouse or a distribution center that was made, 12 years ago, 15 years ago, before the lithium ion battery hazards and some of these other hazards that we're faced with now were developed, maybe those sprinkler systems were sufficient, but with today's fire loads, they are not. And we're seeing, these warehouses and distribution centers burning to the ground because of that fact. Now let's look at aviation. We're going from different types of materials, the composite materials, and the synthetic materials. Lithium-ion batteries are starting to become replacements for what might have been one-time lead-acid batteries. But they're actually part of the airplane. Recycling, we hear about the fires that occur at recycling facilities much or quite often. Again, lithium-ion batteries improperly being disposed of are generally the culprit. And then energy storage systems. We, again, in the news not long ago, heard about Moss Landing and the effects that it had. And it'll be something that we're going to talk about in the presentation as well. And then we look at maritime. How many times have we seen those ro-ro ships where, they're out at sea and there's a EV or there's a fire that takes place? No place to really go when you're out on a ship. But when I get into and start talking a little bit about those modern buildings, again, the massive storage, 3.5 to 10 million square feet. These are getting to be and possibly can be death traps for firefighters because you are looking at such a high ceiling height in some instances and high shelving that if there is a fire, and if the firefighters do make entry into and start, working their way to where the scene of the fire is and hook up to maybe a standpipe that's deep inside the structure, because, maybe early on that smoke is rising up. Problem becomes is as that fire, if it continues to grow, that smoke all of a sudden now starts to bank down. Firefighters become disoriented and lost. And yeah, they'll follow a hose, but it follows back to maybe a post where there was a standpipe connection that they had connected their hose to. It may not come all the way outside the building because those buildings could be massive in size. So the things that we need to look at. What can we do to helpfully maybe take an old system and improve it? Again, when we sit there and we start looking at the codes and standards, you know, you're looking at, today you realize a problem. It may be 2 years before you can put public comment into NFPA to make any type of a change to that. And, by the time that's done and things take place, there may be another hazard, and you have to then wait, until that standard becomes open for changes again. So it's a long process that maybe what needs to happen is we need to figure out a way where when we see a problem, we need to be able to come up with some type of maybe a system or a way where we can address it a little bit quicker. And I'm going to talk a little bit more about that and use parking lots as an example. As I said, from the reports that I read, the fire that just happened in Jacksonville was a full-size BMW. that wasn't an EV vehicle from what I was able to understand, and the fire started from underneath in the engine compartment area. Um, so while that took place and ended up, burning up or damaging up to 50 vehicles, we also have the hazards of the EV vehicles that we constantly read about. When these burn, they burn extremely hot. They give off the toxic gases, and they are always, when I go through and I kind of pay attention when I go to these different parking structures. I always notice that it seems like the charging stations always seem to be placed close to where the elevators are, close to the stairways or close to the exits. And I've never understood, if we've got something that's supposedly going to be such a hazard, why are we possibly impeding our egresses by putting these vehicles in place without, in many cases, any type of a fire protection system. And the reason why I wanted to bring up the parking structure is because when I talk to many of the experts here in the United States, when we look at a true fire protection system that can deal with the hazard other than just plain water, because we know when we hear the reports of water on lithium-ion batteries, it's always copious amounts. And then we look at the reports and we, after the fact, and they're showing 30, 40, 50,000 gallons of water, or in the case of others, possibly millions of gallons of waters. But yet, if we look at a report that was done not long ago, and I've got a video that I'll be showing here later about it, and it's going to be from AP Plus. Um, and when I mention it now, I'll play the video when we get to it, but just understand that, we're 3 to 5 years away from what I'm going to show you later on in the presentation here in the United States because of how slow we are to change our codes and standards. So we need to sit there and look at ways that we can sit there, and when we start to see some of these problems and some of these hazards, how can we sit there and address and do the testing that's needed to update these codes and standards to meet and be able to, again, hit the challenge head on, rather than waiting years and years and years for the codes and standards to basically open up for the process. But we look at how all of these are taking place, and we're going to start to looking at these lithium ion batteries. And, again, we're looking at, the forecast of how the industry, as far as lithium ion batteries, is going to continue to grow. Here they're showing that, the lithium ion batteries and the cells forecast to increase from that 700 gigawatt hours that is now in 2022 up to 4,700 gigawatt hours by 2030. Now that's a huge increase. The batteries are not going to go away. I know many people when we talk about lithium-ion battery vehicles and fleet vehicles, buses and things like that, people will always say, "Well, the grid's not going to support it." And you're right, the grid won't support it. That's why battery energy storage systems are coming to the market. Because what's going to end up happening is it's going to be batteries charging batteries. So when you sit there and you start getting into these areas where you're going to have a lot of EVs that might need to be charged, don't be surprised if not far from that location will be a battery energy storage system. Something where they can have the power nearby and it's not going to be needed off of the grid immediately. So we look at, here an event that took place. I mentioned, I think a little bit ago, that Moss Landing. Again, here we had a facility that had a fire. And, as it shows here, this facility burned for 5 days. Close to 99,000 batteries were involved in the fire. But the thing is when we sit there and start looking at what took place here, it didn't just affect that facility. Look at the number of residents that were required to be evacuated. And it wasn't just for a short term. They were evacuated for at least 24 hours, some possibly more. While from reports and things that I've read on this particular incident from the EPA and the different organizations that were doing air monitoring, they never felt that there was any risk to the public. again, you still have those toxins that are going downwind. How far downwind did they actually do their testing? Was it just in the immediate area? We know that, as that heat rises up into the air, as it cools, that's going to start banking down someplace, and possibly maybe further downwind is where some of those tests should have been taken. Um, so there's a lot of things that we need to be looking at when we sit there and start, taking and figuring out how we need to be looking at, the codes and standards and how we need to address them. But when we look at, the districts, and, what happened here, the the response was, as they showed, robust. They based on what was considered a worst case scenario. But when we look at, what took place, it was basically ended up being, pretty much just a let it burn type of thing. So the people that really were affected, again, were the public, because while it was burning, we had to keep people evacuated to keep them safe. We need to sit there and look at ways that we can protect these facilities so that it doesn't impact the community. If we can come up with a fire protection system that can address that hazard without impacting the community, without causing a need for that copious amounts of water, the millions and millions of gallons of water, if we do decide to make an offensive approach. Let's look at see how we can sit there and how we can address and how we can deal with these hazards today. There's a lot of things that we can do in being able to deal with it. When we look at the indirect consequences, I've talked about the potential for, the pollution and fines, the water pollution, air pollution, especially. If we are getting into and trying to use the copious amounts of water, yes, that does become the hazard. If you're an insurance company, again, you start getting people that have to be evacuated because of a fire, be it in a battery energy storage system, a parking structure, a distribution center, because of what's inside, be it hazardous materials. People are going to be looking for some type of, payment, for being displaced. Not only that, but we sit there and we start looking at the loss, the amount of loss. That's going to lead to increases in insurance. So if we again can better protect these facilities, okay, and reduce the loss and the effect on the community, we can hopefully then help to reduce the damages. The big thing is let's look at the reputation of the company that owned that Moss Landing facility. What do you think that has had as far as an impact on their reputation? As far as them possibly looking to build any other systems. Um, Again, there's a lot of things that come anytime there is a massive fire, and you have a company that's trying to build and grow and expand, and all of a sudden this kind of puts a little bit of a twist in things. The
Excuse me,
community
Jeff.
impact. Yes,
Sorry for bother. Can you, because we are looking in your screen a black square?
a black square
Yes, in the bottom to your right,
to my left. I
or
have
other side to the right.
over here.
Yes.
I have nothing open there. Hmm. Is it still there?
Yes, it's still there.
All right, let me, because it's not showing up on my screen. That's what I am lost here. Let me stop sharing and try resharing.
Now,
Is it still there?
yes, still there.
Ah, I don't know what's causing it, Ron. It's not on my screen.
Yes,
Let me,
we can continue. It's only when you talk on to your rights, you have some word that we cannot see very well.
okay, all right. I'll try to explain if there's anything important in that area.
Yeah, sorry.
Okay, no, thank you for letting me know. Okay, well, getting back into it, as we sit there and start looking again, the community and the economic impact that can take place, that personal impact. If you have people that are being displaced from their homes for any length of time, again, pets, they need to be able to get to work. They need to be able to, take care of business and so on. So it's just a huge impact that any type of a major disaster can have. And when we sit there and we look at that community impact, again, let's look at those instances of fire that have taken place at the airports. Not only did it disrupt as far as the foot traffic or the auto traffic, but how about the air traffic? I mean, they're shutting down airports as far as takeoffs and landings for hours. What type of an impact do you think that has around the world? Because it's not just to that airport, it's any place where a flight may be leaving to fly into that particular airport. So that interruption is I mean massive. That many times we don't even think of it when it gets into that business and revenue loss. And that revenue loss, again, we start looking at the areas along the highway that I'll get into as we talk about it. But as we sit there, we start looking at the time frame for the evolving codes and standards. Here in 2021, FM Global, they're looking at these parking structures and the need to increase the amount of basically fire protection. And so what do they do is they change the rating from an H2 to an H3 to help and make the push to increase that protection. NFPA 13 again in 2022. Now here we got roughly a year later. They're also now pushing for and wanting to change the parking structure rating from a group 1 to a group 2. Again, now we're looking a year later, get NFPA 1888A and some of the things that are taking place and then now in 2024. So you can see right now, all the different codes and standards that need to sit there and be looked at and changed. And, the slow progression, starting in 21 and 24 now. And again, that is just, a start. There may be 3, 4 other codes that might need to be addressed. And you know what? We can't address those until this one gets addressed. So it's a very, very slow process that to myself as a firefighter, I feel it's something that we need to look at and see if there's some way we can't streamline the process so that if one code is affecting another code, we shouldn't have to wait 2 or 3 years because that code isn't up for a revision. There needs to be some type of a process where if one code's affecting another, we need to be able to look at how we can get that impacted and help it with the change sooner. Because again, it all has to do with life safety. So now we get into, again, NFPA 18A, the agent category where encapsulator agents are. When we look at the agent and NFPA 18A, again, as I said, the company's been around since 1997, 27 years. Many products are coming out and using the term encapsulator or encapsulator in their title or in the description of their product and how it works. But yet they're not encapsulator agents because they can't meet Section 7.7, the test protocol for the standard. So as foams have test protocols, so does an encapsulator agent. We get into NFPA 409. We start looking, with the lithium ion batteries and the hazards and aviation, dealing with aircraft hangars, and how we're going to be able to better protect them. Well, in 2023, we submitted to the FAA and we got included into the AC 150 5210 6 Echo Circular, and we're recognized as a complementary agent, just like the powders and other products. So we're now as a complementary agent for use, and the big push was again how many of our support vehicles at the airports are now being converted over to lithium ion batteries. Those tugs that move our luggage around, the vehicles that push the airplanes away from the gate. These are all being converted over from, the gas or diesel to lithium ion battery powered. So in the process thereof, we need to sit there and look at how we're going to be able to protect our airport, and the infrastructure as well as the aircraft in the event we have a one of those vehicles or something occur that happens. Now, I'm going to show a real quick video because, when we sit there, we start talking about the F500, NFPA 18A, we start talking about, foam. When we look at NFPA 18A, we're talking about an encapsulator agent. And to give you an idea how we're different than a foam is, our product starts with a molecule that has a polar head, loves water, non-polar tail that fears water. The polar head will do anything it can do to mix in the water. The tail will do anything it can to stay away from the water. And because of that, when the concentrate is introduced into water, it automatically and instantly orients into these spherical micelles. So now we can batch mix it, we can induct it, we can put it into sprinkler systems, as far as building protection, fire hoses. And as that water comes out with the concentrate inside of those spherical micelles, the spherical micelles that are closest to the surface because it takes less energy, they're going to break apart. And I've now put a skin on the surface of each and every water droplet. So unlike foam, where foam is going to work on a mechanical basis, and I say that because it causes a separation between the fuel and the oxygen. When we sit there and start looking at our encapsulator agent is going to work on a chemical molecular basis. Again, I'm changing a water droplet, and now how that water droplet is going to be effective at being able to cool and extinguish. We look at, for instance, the different types of agents. Look at a Class A foam. When we look at that, it's effective on pretty much your Class A um, hazards. We look at, your Class B, 2D, your foams are efficient. However, water is not as effective unless you are trained in how to use water on a Class B fire. We look at, your three-dimensional fires. Foam are not. If you look at NFPA 11, in the Annex A11 of NFPA 11, it even states in there, foam is not suitable for three-dimensional flowing liquid fuel fires or gas fires. But yet, what have we always used? I mean, if we sit there and you look at it, as normal firefighters, we were, always trained on how to use foam. You got a flammable liquid fire, use foam. But you know what? When we got into the actual training, we never really got into the three-dimensional aspects of it. But that's why if you are an ARF member, you work for Crash Fire Rescue, you have dual agent extinguishers. You've got the dry powder and you have the foam because they know that foam doesn't work on a three-dimensional fire. So they needed something that could help them extinguish those types of fires. We get into Class C fires. Again, waters and foams aren't efficient. Where the foam is actually more of a hazard than even the plain water. I mean, plain water, if we use a broken pattern, the misting pattern, we can hit those types of fires. If we use foam, however, the foam, because of the bubbles, are going to cause a bubble-to-bubble interaction, and it's going to basically create a conduit back to whoever's holding that hand line or whatever is applying the foam. So foam is definitely out for any type of a Class C fire. We get into the Class D metals, the titaniums, magnesiums. Again, your foams and water aren't recommended. You have those huge fireballs that go up into the air of the molten metal. I see videos where people and firefighters are getting showered, burning holes in their turnout gear and being injured because of those types. And then again, we get into the lithium ion batteries, and from test reports from around the world, they all show that foam is non-effective on a lithium ion battery fire. Water, while they're pushing, and it's, seems to be the big thing, again, it's not effective. How many times when water is used do we hear about the reignition hours, days, possibly weeks later. But when we look at the F500 side, on all of these classes of fires, it's very effective. Now, as I said at the very, very beginning of the presentation, been around since 1997. We've been around and it's the product has been tested on these different hazards. It's not that the product was developed, okay, to be able to extinguish the hazard, but it was developed and found to be very effective on these types of hazards. So as it seems like new hazards in the fire service come to light, our product becomes and it gets tested on these, and we find out that we are a very, very viable solution in being able to deal with these high hazards. And the question becomes why? Again, because we're working on that chemical molecular basis. Okay, we're not just working on trying to cause a separation between the heat and the fuel. We're removing the heat. We're improving the oxygen by removing the toxins and the gases. We're having a multiple effect on being able to deal with the hazards where, again, the foam is just working on that one. I mentioned in earlier when we were talking the Section 7.7 because many products are coming to market making a claim of being an encapsulator, having encapsulation in the app or in the description of the product or how they work. The problem becomes if we are looking for a true encapsulator agent that meets NFPA 18A, we need to go to Section 7.7. This is the qualification test for an encapsulator agent. And you'll see in it, the Section 7.7 test is basically a test, it's a spherical micelle stability test. So what we want to do is we want to test to make sure that we have stable spherical micelles that are able to encapsulate our fuels, toxins, etc., in the presence of high heat. And if we can't, then we're truly not an NFPA 18A encapsulator agent. We get into Annex A 4.3 of section of NFPA 18A. Again, many people refer to this section because it deals with independent third-party testing on lithium-ion battery hazards from around the world. We've got some, very, very, what do you want to say, large institutes. We've got TU Clausthal, Fraunhofer Institute. Anyway, we've got many agencies that have tested and have shared their reports with the world on how effective F500 is on being able to deal with the lithium-ion battery hazards. The problem because is other people again start to sit there and refer to this in their again description of how their product works. We need to understand that if they haven't been able to pass NFPA 18A Section 7.7 testing, then they are not basically an agent in a category that was used in this A4.3 testing. So as we look at and start talking about, tests and accreditations, as I've said, there's been a lot. We've got, the FILC over in Korea, EPA, Federal Aviation Administration, NIOSH, AP Plus. We'll be seeing a video here shortly. Johnson Controls, Port Authority of New York, New Jersey. There's been many third-party agencies that have tested the agent. When we look at it also, the question then becomes too, because everybody asks, what about the PFAS, the fluorinated ingredients? Our product has been tested by, again, many countries, including here in the United States. We have done gel labs and reports that will be gladly shared that show there are no PFAS ingredients, no fluorinated ingredients in F500. So when we sit there and now start looking at how can we get F500 into our sprinkler systems, let's look at sprinkler densities. Because again, I started talking about those older distribution centers or warehouses that maybe 10, 15, 20 years ago um, had a sprinkler density that was sufficient for the codes of the time that met the occupancy, what that warehouse or distribution center was being used for. But since then, that load has changed. More modern, toys, batteries, whatever it might be. Anyway, the occupancies changed, the fire loads increased. Does that system still meet today's codes? Do we need to rip the entire system out, or can we add something into the existing system that might help bring it up to a code or a standard that's maybe meets today's or possibly even exceeds today's standards? Instead of being able to possibly just control the fire until the fire department arrives, how about we have a system that may be able to extinguish the fire before the fire department arrives? So we look at how and what the abilities of encapsulator agent is. And again, when we sit there and we look, the ability to remove and encapsulate explosive vapors. One of the things that a test report has shown is hydrogen gas. CO2, but hydrogen gas, very explosive. We find that F500 is very, very effective at being able to encapsulate and remove those hazards, that hydrogen gas. With flammable diesel gas, or even natural gas, again, we can sit there and we can encapsulate and actually eliminate those explosive vapors from finding an ignition source and causing an explosion from occurring. So there's a lot of things in a lot of high hazard areas where F500 could be used in sprinkler systems to help protect and prevent explosions or fires from occurring, or in the event of a fire, extinguish. Big thing is, we're looking at trying to, because of how effective the agent is in being able to cool and extinguish, and we'll see that here as we continue on, but we're going to have less of an environmental impact because we're going to need less water to deal with the types of fires that we're using thousands and thousands of gallons of water on, so we can protect our infrastructure. I had mentioned this AP plus testing with parking structures, and this is again getting into, and I'm going to show that testing that was done because again, as I said, when we look at what this was doing and what they're trying to accomplish, they're trying to find a system to be able to protect a parking structure or tunnel. And when we look at the AP Plus laboratory, is a large facility, basically a large group, as it shows here, with 26,000 employees in more than 70 countries. They're a world leader. They are somewhat like RUL. AP Plus and UL do look at and accept each other's certifications and testings. But again, here we worked with AP Plus, and we started working with getting a test set up with, over in Spain. And what we're doing here in this test, so you can see here in this picture, we've got two vehicles. The vehicle that's in the middle has got a battery underneath. The other one is an ICE vehicle, internal engine, combustion engine. We see that the battery is a 50.94 kilowatt lithium ion batteries. It gives you some of the parameters. One of the things also is on the side here, you'll see the open space. The open space on the side is going to be considered an emergency egress. So what we need to do is we need to watch and see how effective, the system can be. The battery, just to give you some additional information, was at 100% state of charge. They allowed this to burn so that, again, what they want to do is this basically make it so that it was like the car was at a parking. The point of the test was to make certain that the fire was confined to the vehicle of origin, that it did not have an effect on the vehicle next to it, which would have been great there in Florida. The thermal runaway, we wanted to make sure that it was confirmed, and it was. The evacuation corridor that I had mentioned, the temperature in that corridor could not exceed 60 degrees C. And at the ceiling height, it couldn't exceed 70 degrees C. They're trying to make certain that it's safe for somebody to be able to walk by without, getting severely burned. And number two, at the ceiling height, that they weren't going to have temperatures that were going to start to have a compromising effect on the structure itself, which might cause a collapse, building collapse. This is dealing with our diamond doser fire protection system. Again, it adds F500 concentrate into the water. It does not require any electricity, which makes it very, again, um, effective and cost effective. Here we again have the fire. It's started. It's going to go into, allowed to go into that thermal runaway, thermal propagation. I want to point out, look at the smoke. Yeah, they do have some ventilation, but still, look at how much of an effect the F500 solution is having on the smoke. Look at the fire. Here you have the lithium-ion battery. Now, the battery just burnt as that hazardous toxins go into the F500 solution. Again, even the battery smoke gets encapsulated. While again, the test, when they had designed the test, it wasn't with the uh, result of seeing the fire extinguished. It was wanting to see if they could control the fire until possibly first responders could arrive on scene and extinguish. But yet they saw great success. They exceeded what they were expecting. Basically, there was no fire spread. And by the time at the end of the 60 minutes, they again saw that the fire was extinguished, even though that wasn't what they had intended this system to do. So the system was even more effective than they thought it would be. And because of that, it has now received through AP Plus a certification. Give you some of the specifications. It was is here, as you can see, they were using these Tyco D3 nozzles. It was a system that was set up with a flow rate, basically 66 gallons per minute. Extinguishing area, 404 feet. But again, working pressure. These are all things that are very, very easy to work with and to be able to design with us. And, you will work with us and we could get these systems in place and to help you out in trying to specify the correct diamond doser to meet your needs. I want to talk again because as we sat there and we talked about the highway instance, here, we look at a case history that happened on I-95 in Indian Springs in Nye County, Nevada. Um, this is an area that is out in the desert. There is no water supply anywhere near where this took place. It happened in September. There was, again, due to this truck accident, one truck was carrying lumber, and this other truck was 31,000 pounds of lithium-ion batteries. The lithium-ion batteries did ignite. They did catch on fire. The fire department in route was informed that they were dealing with a lithium-ion battery fire. So this county had recently did some training and accepted and purchased F500, and they were so impressed with how effective it was that they had gone and ordered a trailer that could carry a tote of F500 on it. So they had taken delivery of this, and luckily it was just weeks before this particular incident took place. And so the incident commander that was being en route called for the trailer to be brought to the scene. So when they arrived, he basically ordered that no action be taken. They were waiting for this trailer to arrive with the F500 before they took any type of action because they were, again, limited to the water that they had on the apparatus only. There was no other water. It was going to take them hours to drive back and forth trying to, refill their trucks and come back. So we look at what happened there, and the fire department was able to, when they made their attack, extinguish this fire in like 5 to 7 minutes in talking with the chief. He said that they used 5,500 gallons of water at a 3% solution. They had called for Las Vegas hazmat crews to come to assist them as far as air monitoring and to sample as far as water runoff. And when they found out en route that, well, hold it, you only use 5,500 gallons of water and the fire's out, there's no air monitoring that needs to take place because the fire's out and you only use 5,500 gallons of water. Out in the desert, it's probably going to evaporate before we get there. So they basically, went back home. However, we look at that in comparison to another incident that took place. Again, this was with a semi truck in August of 2024 that took place, and that one took 50,000 gallons of water plus airdrops in California to extinguish the fire. So when we sit there again, start looking at that environmental impact. Let's look at the effect. How long was the I-95 uh, situation? Basically, I think it was about 16 or 18 hours that the Nye County incident took place. Yet in California, we're looking at days. How much money and commerce was lost? How much of an effect did the two fires have? And when we sit there and we start looking at. So when we look at applying the encapsulator agents, we kind of need to size and scale the application to the type of fire that we have. So we're looking at those small fires, the scooters, e-bikes, and things like that. Small line of defense. We could probably use, your extinguishers. We start getting into something a little bigger. We have a self ducting nozzle or a TKO nozzle, and so on and so forth. But we start getting into large fires. Let's look at, sprinkler systems. Let's look at being able to improve sprinkler systems. And instead of having a system that's good for basically today's hazards, we can sit there and have that so it's good for tomorrow's hazards as well. As I say, it's a 21st century extinguishing agent, for the 21st century fires, rather than using, 19th century technology and trying to adopt it. We're finding out that it's not working. So again, here's a picture of a diamond doser showing you how it works. It is gravity fed as far as the concentrate coming in. As you can see here, there's no electricity that's required. It's all based upon water flow. And again, what's nice about these is if you have, just one or two sprinkler heads that go off, or you have, 10 sprinkler heads that go off. The system isn't designed so that it is set at one specific flow rate. It has a large flow range. That flow range might be from 100 gallons up to 1,500 gallons. So these systems will be worked and engineered and designed based upon the calculations and the flow rates and information that you share with us and we can work with. As I've said, it's able to deal with today's high hazards. It's a multi-class, three-dimensional extinguishing agent that will work not only on the liquids but also the vapors. It reduces the carcinogens and the toxins in the soot and the smoke. So firefighters, with cancer being such a high incident rate within the fire service, we can actually start to reduce our exposure to many of those carcinogens and the toxins. So the sustainability, the minimal maintenance, one of the nice things, because again, you're supposed to do annual testing with your sprinkler systems, especially if they have some type of an agent that's being introduced. Well, with the diamond doser, you can actually sit there and you can do your testing, your annual test, without having to create a solution. You can bypass and collect the concentrate, do your calculations for your flow rate, um, collect the concentrate into a bucket, and now you have a sample that you can send in to have the annual testing on the concentrate done. So it makes it very, very effective and cost efficient. So the simplicity, can we install it into an existing system? And the answer is yes. Again, we'll work with you on the riser size, We'll get some information, and based on the information and the responses we get back from you, we will sit there and we will help. It talks about, can two diamond dosers be installed in parallel? And the answer again is yes. Um, as long as we create, the harmonic pipe flow, and keep, the flow rates in mind, things can be accomplished. As far as the pressure tank to store the F500 concentrate, no, as I said earlier, it's gravity fed. So all we have to do is that concentrate tank just needs to be slightly elevated above the height of the diamond dozer, usually on a pedestal of some sort, and it will be just fine. And as far as AHJs and approvals for these systems, yes, we've had many give their approvals. If we look at NFPA 18A, there are things in there as far as systems, design and basically information on there that helps and shows that this can be very effectively and easily added into fire protection systems. So with that, I mean, we'd like to sit there and invite you to call, email. Here's our phone number, our email, info@hct-world.com. We'll be more than happy to help you out in helping to design a system either for a new facility, in improve an existing, or whatever we can do to help you out and get, again, you up into the 21st century and being able to improve the building sprinkler systems and, again, fire protection. With that, I appreciate and thank you for sharing and taking your time joining us today. Hernan.
Hello, Jeff. Thank you. We have a question here from Patrick. He said, if you are only collecting the concentrate for testing, how do you ensure that the doser is actually introducing the correct percentage of concentrate into the system?
Well, that's done with when we sit there and we do our installations. We will have a tech come out and they do the certification. They will test the solution to make sure that the diamond doser is adding the correct solution into the water, and that you're getting whatever the percentage is, because again, based on the occupancy, it might be a 1% up to a 3% solution that's needed to be able to identify or be able to deal with the hazard.
See, the other question that we don't have the name is there a list of a sprinkler system installation with the Diamond Dozer and A500 EA?
Are they looking for ones that we've already installed?
Yes.
If you're
The
looking,
answer,
yeah,
the answer is yes.
yeah, we've got many. But
Yes.
just off the top of my head, I know we have with the lithium ion battery hazard, we have many at the Tesla Gigafactory. We have many systems that are at power plants, protecting under turbine lube oil systems, protecting silos, conveyor belts. We have many applications in many different areas. So yes, we do have a
When
bunch of systems that
when
are installed.
when you receive, I don't know who made this question because it's without name. When you receive the email from our company or from me, you can return back with this question, and we can share with you the list of the project that we have the Diamond Dozer with A300. We have other question from Patrick is, would they have to come annually to test that then? What if it malfunctions? How will you know?
Well, the as far as malfunctions, the minimal problem that you're going to have, because again, there's not a lot of moving parts. Again, that water-driven Porsche's got a wheel that the water's going to turn. That then actual goes and activates the pump to inject the concentrate into. So on a quarterly basis, there's a wrench that will come with the diamond doser, and the basically is basically putting the wrench onto the um, port on the diamond doser and making sure that that wheel turns freely. That is pretty much the only maintenance. As far as quarterly, that's required. And then as far as the annual, where you're doing the flow test, again, what will happen is they will flow water. Instead of making a solution, again, as I said, they can collect the concentrate separately. They can bypass so that instead of ejecting in and based on the gallons of water that have been flowing for whatever percentage you're looking for, they can calculate how much concentrate should be collected, and then they would be able to take that concentrate and send it in to HCT to have it tested, make sure that it is still good. So, you're not going to create inexpensive, again, solution that you might have to get a frac tank in to collect the runoff or whatnot. You're only going to be running water for your testing.
Okay. We have other question on the chat that somebody answered. And Fonda asks, is this technology effective on batteries that are located under a vehicle? You saw the video that we test on Spain, that the idea is to prevent the propagation. But the answer for this question is yes. We test in South Korea with batteries, and we create a protocol to put a device under the car to cool the batteries, and with other hosts we extinguish the battery. See, we can share the chronology, or you can go to our website under lithium batteries, and you can download the chronology with all these tests, especially the tests from Korea that I participate, with a video that you can see how you can extinguish the batteries under the car. Okay. In this moment, Jeff, we don't have other question in the chat of question and answer. Heather put here in the chat the lithium batteries link. Please,
Okay.
Heather, if you can put the chronology that the people can enter in the chronology. When you enter in this PDF document, you will see in some red buttons that you can open. When you click in the red buttons, you can open all the document, all the videos. You have more than 15 document or test report that you can open from one PDF.
Yeah.
See, you can go to looking for 24 and 23 from 2017. You have all the tests on lithium battery with the test report that you can open. We have some minutes. If somebody wants to raise the hand, that I can give you opportunity to open the microphone to make any question, or somebody want to put a question on the chat of question and answer, or here in the chat that we are looking. Let me see, because we have.
Yeah, I see one that's
Hey,
asking.
John asked, what is the shelf life of A500?
The shelf life of F500 is 15 years in an unopened pail. So it is very stable. I will say that, it can be longer. Is if you get to that 15-year time frame and you want to send a sample of the product in, and that's what's nice about those diamond doser systems. In applications and industry, as long as you are sending in those samples every year, we will test that sample and give you a report back as to whether or not that agent is still good. I will say that product that was made in the original batch back in 1997 still tests good, so we could increase it. You can blame a bunch of us firefighters asking the president not to increase the shelf life because we want people to use the product, not put it in the back room collecting dust.
Okay, thank you. Let me see, because I believe we have other question. Fonda said, if there an inspection process of frequency for the system?
Well, again, many times when you put in fire suppression systems, they do require annual testing. I'm not sure as far as AHJs or what state codes are, but most of the time they do require flow testing annually. So again, it would just go along with whatever the requirements are for your jurisdiction.
Okay, thank you, Jeff. Any other question? This is your moment. See, Thomas, the answer he asked if we will send the certificate. Yes, Thomas, if you need a certificate, please let us know and we will send you the certificate. Okay. The last two questions. If somebody want to open the microphone and put in the chat. Hector Guzman dice, is suitable for ethanol? The answer is yes.
Yes.
But Jeff, you are the specialist.
Yeah, just to give you, the answer to that question, Hector, what led me to F500 was when I retired from the fire department, I actually started doing consulting with the ethanol industry. And again, in trying to find a solution to deal with, like you say, the fires that might occur in, different areas of the plant. Again, many three-dimensional aspect type fires. My recommendation to the ethanol industry was to switch to the F500 because it was more effective than the AR-AFFF foams.
We have the last question here in the chat from Dirk from South Africa. And he said, would we need to send the samples to USA only?
What was the question again?
Would we need to send the samples to USA only? The answer is yes.
Yes. Yeah, that's where we test it.
Yes. Okay. Let me see. I want to be sure that. Come on. Mood asks in the chat, would existing equipment that we have for foam, such as inline inductor, be okay to use with A500?
Inline eductors, yes. Basically you're using that for foam firefighters and so on. Very familiar with them. Onboard foam proportioning systems that might be on fire apparatus. Yes, F500 can be used with those with no problems. The only thing is it'll be depending on what your hazard is. Either again anywhere from a half to 3%.
And this is pickup tube for foam making nozzles.
Pickup tube for foam. Again, if the nozzle
Yes.
is a foam, if the nozzle is a foam nozzle where it's air aspirated, you have like the tube on it, that is going to try to enhance bubbles. Then no, you don't want to use those types of nozzles with F500. F500, you have to understand, is changing the makeup of a water droplet. And so the smaller the water droplet, the more effective it is going to be at being able to cool, extinguish, and encapsulate. So that being said, anything that's going to cause this product to, try to make a bubble is going to ruin the effectiveness and the efficiency of it. So, if it is a pickup tube that goes to a nozzle like a 2.5 nozzle that has a pickup tube, but there's no air aspirating or no tube on the end of it that's going to force it to make bubbles, then yeah, that'd be fine. It's not going to have an effect. The product will work just fine with those nozzles.
Okay. Thank you so much, Chef. You answered the question of Mood. Mood, let me know if you want to ask the last question. It's your opportunity before we say goodbye. But yes. Again, thank you to everybody for all your questions. Thank you so much to participate in this webinar. Please contact us from our website, from our social media, and we will send some of this information that you can enter on our YouTube channel, that you can enter in our website to download the brochure, to download the information that we have to everybody. And please let us know if you need to have a meeting with our local specialist to have a training or to receive a training to make a demo and you understand better this encapsulator technology and how you can apply in the different systems. Diamond doser, bladder tan, online, inline, a doctor, or inside of the trucks. Thank you, Jeff, for your time. Thank you for your presentation. And please, you can say goodbye to all our people from all around the world.
Yes, well, again, thank you all for joining us today. It's been my pleasure. Sorry about the little technical glitch with the little black space. I don't know what took place there, but again, thank you for your attendance. Please, if you have any questions, contact us. We're here to help. Our big thing, as I've said, being a firefighter, is to help in protecting places, public, and facilities. So by all means, let us help you do that and get our codes changed. We need to speed that process up. Thank you.
Okay. Thank you, everybody. Have a wonderful evening, wonderful morning, and ciao. Goodbye. Adios. Bye-bye.
Bye-bye.